everybody. So before we begin our Unit 5, we're going to do a little review of the properties of exponents, okay? So exponents, as you know, are used to indicate powers, and we have some properties of these exponents that we're going to review here before we begin. So first of all, one of these properties is anything to the 0 power is equal to 1, okay? And again, assume that no denominator is equal to 0, and m and n are positive integers. So a cannot be equal to 0, okay? So a is always going to be some sort of number. So anything equal to 0 or anything to the 0 power is going to be equal to 1. So here's an example here. I have this y to the 0 power. So this would just become 3x squared and then times 1, which would just become then 3x squared. And that would be it. Okay. Our next property is anything to the negative power. That is not simplified if you ever come across a negative power. So we have to simplify that. And all that means is that whenever we have a negative power, it wants to go to the opposite. So if it's in the numerator, it wants to go to the denominator. If we have a negative power in the denominator, it wants to go to the numerator, okay? So in this case, this particular negative power wants to go down below. And in the other case, in the numerator down below, or the denominator down here, this particular term wants to go upstairs, okay? So we're going to write this guy as 2y cubed, and then we're going to put the z cubed upstairs, z cubed. Okay, and then we're going to write the 3 on the bottom stays there, and then that x squared is going to go downstairs. Oops, sorry about that. X squared is going to go downstairs. Okay, so simplified, we have our, I don't know where that line came from, 2y cubed, z cubed over 3x squared. Okay, and then that would be simplified there. Okay, so no negative powers for a simplified term. Okay, our next one is if we have the same base here, we have the same base and multiplied together, we end up adding our powers. Okay, so here we have the same base, so we're going to take x to the 2 plus 4, which is going to give us x to the 6. Sometimes people get confused on which is which between this one and this one. Just remember, if I come down here and I go x times x would be my first one, right? And if I take this guy, x times x times x times x, because the power indicates how many times it's being multiplied together. So I have 2 here, I have 2 x's here, I have 4 x's here, so altogether I have 6 x's, okay? So sometimes you can kind of remind yourself just kind of doing a simple example like that. Over here, we have a power raised to a power. In that case, we're going to have this x squared 4 different times, right? So x squared times x squared times x squared times x squared. So we have 2 x's here, 2 x's here, 2 x's here, and 2 x's here. So we have, in all together, we have 8 x's, x to the 8th. And so in this case, we have a power to a power, we multiply, right? So that's going to be x to the 2 times 4, which gives us x to the 8th power. Okay, so that's how you can kind of determine between these two properties here. Okay, next up we have, what if we have 2 terms in parentheses here raised to a power? This is kind of like distributive property, but it's not technically distributive property, but we kind of distribute the power. Don't forget about number terms because that's still a term. So this is going to be, this is a power of 1, power of 1, power of 1. So we multiply each of those powers. So 2 to the 1 times 2 is 2. X to the 1 times 2 is 2. And y to the 1 times 2 is 2. Okay, so it would be 4 x squared y squared. If there was a power there other than 1, you'd multiply those powers. So you multiply those powers, it kind of gets distributed to all 3 terms. Okay, so this would be simplified here. Okay, and next up is if we have a quotient raised to a power. Similar thing, both of these powers get multiplied by that quotient. So in this case, it would be 2 cubed, x cubed, oh gosh, I can't write that, and then y to the 2 times 3. Okay, so 2 cubed would be 8, x cubed, and then y to the 2 times 3 would be y to the 6th. And then that would be simplified. Okay. All right, next up we have, what if we're dividing by the same base raised to a power divided by same base raised to a power, okay? And so in this case, we subtract our top power subtracting our bottom power. Okay, so here we have 3, we have a similar base here. We have the x base, we're going to go x to the 5 minus 2 So the power of the numerator minus the power of the denominator. And then we have our y bases here. So we're going to go y to the 2 minus 3. Okay. So we have 3 to the x cubed, y to the negative 1. Now this isn't simplified, right? Because this has a negative power. So this is going to tell us we want to go downstairs. Okay. So what we want to do is write 3x cubed over y to the first power. And now that's simplified. Okay. All right. So let's do a couple of examples. Maybe you want to pause these and do them on your own and come back and see how you do. And then we'll go from there. Okay, so here, first of all, I'm going to go ahead and multiply my two numbers. So 7 times negative 2 is negative 14. Then I'll go a to the second times a to the negative 5th. Right? A second times a to the negative 5th. Now that means we're going to add our powers. So negative 14 to a to the 2 plus negative 5. Okay, so negative 14, a to the negative 3rd. This negative power tells us I want to go downstairs. So I'm going to go negative 14 over a cubed. Once you move that power, it's no longer negative anymore. Okay, and so now that's what our simplified is, negative 14 over a cubed. All right, let's go over to this guy over here. We have a 2 in the numerator. We have a bunch of division here, so I'm going to go ahead and take a to the 1 minus 3, b to the 5 minus 1, and c to the 2 minus 2. 2 minus 2, there we go. 2 times a to the negative 2, b to the 4th power, and c to the 0 power. Well, c is just going to become 1, right? So then, and this guy is going to want to go downstairs. So we're going to go 2b to the 4th over a squared. And c kind of goes away because it's just 1. And there we are, simplified. Okay? So that's what we're working on today, is just applying these properties of powers. You have a worksheet in Google Classroom, 5.1 worksheet. Make sure to show all of your work, okay, and your answers. And then I will see you either in class or in Zoom. All right, take care. Bye-bye.